discovery engine and say, okay, now go do discovery, but use the credentials that I have that I got by compromising this machine over there. It's then going to go through and, as part of the normal discovery process, enumerate every user, enumerate every share, and now when you do your brute force again, it has a much wider list of users to go through and brute force. So you just keep feeding data back into the system until it's basically done. And in the example I talked about earlier, done took 20 minutes and got 97 shells from one vulnerable target. So there's a lot, it just goes a lot further than a lot of tools in the market. So I'm going to do a quick demo real quick of the Express workflow. After this, we'll go into kind of a side-by-side comparison of Metasploit Free versus Metasploit Express, kind of give you an idea where that lines up, and then after that, we can do hands-on demos outside. So first off, it's a web product. So probably no surprise there. Everyone uses web interfaces these days, and Nexpose also uses a web interface. Once you install it, you have to create a user account, and from the user account, you create your first project. After your user account's created, you basically get dumped in a screen like this. Login box, password, it's over SSL, it uses Apache, uses Mongrel or Thin on the back end. Self-signed cert, you can swap the cert out if you want to install your own SSL certificate. So once you log in, you get a list of projects. And normally, it's not so much divided into sites so much as projects, because this data is almost temporal. You're not going to want to go through and use the same pen test template for a month or two in a row with the same data, because things change too much. This stuff is pretty much it's temporal data. It's stuff that it gives you a snapshot of the network right then and right there, and you probably want to create a project for each engagement you do. What we're working on in the future is going through and actually creating templates. You can then clone the template to go forward as your base, but right now it's you create a new project for every engagement. So in this case, we're going to say source Boston, and let me find out what network range it's using. I'm on host mode VMware, it's a little bit crazy. Most cases, it'll actually tell you what network range and default it. In this case, I've changed my IP address like 6 times since I started it up, so it's a little bit confused. So we're going to scan the entire /24 subnet. Oh, sorry, we're going to create the project, and you can see we've got a bunch of options here. Scan, import, Nexpose. From Nexpose, you can see we can run a scan, plug in our credentials. Import, we can import a bunch of different data types. Scan has some different options on it. It's actually, I think my resolution's under the supported size, so it's scrolling off right now. But basically, you can say, give it the defaults and tell it to pick its own default port range, which is pretty comprehensive. It's everything we have an exploit for, plus additional services. You can say, scan this range, but exclude these few targets over here to the side. You can also go through and say, I want to scan the default ports plus these additional ports I know are running web servers or secure shell or some other service you want to target. Or you can say, I want to scan everything but this one port, or you can give it an entirely custom port range like 1 to 65535 and scan every port of the network if you want to. And these options just get passed down to Nmap, basically. There's nothing really fancy about it. UDP Discovery uses our internal auxiliary discovery module that's in Metasploit, so there shouldn't be any surprises there, but does a lot of really cool things. Identify known services, we'll come back to a second pass on the services it couldn't figure out the first time with nmaps-sv option, and then use that information to normalize it and then launch exploits based on what protocols it finds. So it should automatically find web servers, SMB servers, things like that automatically when you have this option enabled. You can also give it an optional username and password over here. This also includes your landman hash. You can just paste the hash into it and it uses it directly. So let's go through and use the existing username and password to do better enumeration early on. And you can give it like speed and whatnot, speed and timeouts. So we'll tell it to go insane because you don't want to sit here and watch it forever. After you launch a task, you get basically punted to the task log. We're probably going to change this around later on, so it's a little bit less distracting to go straight to it. But you can see basically every command line being run, every option being passed, every module. It automatically scrolls through. So you can see here's kind of the list of the ports we're running. It's a huge port list, lots of fancy options to it. But all we're really trying to do is make sure we cover all the ports we have exploits for and do things in a pretty fast way. Now, if we want to go back to the main listing again and not have to watch the task log, we can just sit here and wait till it's done. And at this point, you can run an Expo scan, you can do anything else you want to do at this point while you're waiting for any particular background task to finish. This is actually generally pretty quick. I think we're just waiting for Nmap to finish, then everything else should fly through. So first target's coming through. VMware host mode gets a little bit crazy with Nmap, so I was running NAT mode previously, and I kept crashing the NAT mode driver. So hopefully this will work. Worst case, we'll go outside and use the demo machines afterwards. There we go. So you'll see the first thing it did so far is Nmap. Now it's going through and doing the UDP probes. So it's just probing every target. You can see it's 7% into it. You can have lots of background tasks. You can stop them whenever you want to. The nice thing about this is you can close your browser, walk away, and it all works on its own. It's not tied to the browser or the instance. It runs in a background process. So you can have lots of background stuff running, keep your exploits running in the background on a target. The software installs just fine on a remote headless server too. So you can install this on a target box, stick it on a colo cloud, add all your listeners to it, and just check on it once now and then to get your sessions and interact with it. So it's not something where you're basically tied to running it locally on a desktop. You can put it anywhere you want, anything running Linux or Windows at this point. So this hopefully will be done here in a second. You can see it's pulling up SNMP information, NTP, SMB, NetBIOS, all sorts of things. It's a pretty small target network, but so it should go pretty quick here. So now that it's got some targets, you'll see them start to show up in the host table. And you don't have fancy OS information until it's done with the fingerprinting side, but you have a basic list of what targets are available. So I've got a couple XPs, Windows 2000 target, another Windows 2008, I think, the host machine itself, and then I think this is actually the scanning target, scanning machine. If not, we'll find out here in a second. So it's going through and it says, hey, I found a SQL server, so I'm going to start probing SQL automatically. It's not going to run probes for services it didn't find during the scan. So it's pretty smart about not trying to check things it's already looked for before. The nice thing about a lot of these things is it gathers information that's a little bit more in depth than most vuln scanning products will, because it gathers information it needs to actually run the exploit. So it's much more concerned about what information do I need about the service to exploit it, not just what vulnerabilities are available or anything else about it. So we've gone through and we finished everything else. Now at this point, we're just going through and normalizing services and trying to identify the ones that didn't figure out the first round. And it's still a little slow, but you can see we've got our target list of systems, 2000 box, XP, 2008 server, XP, another Linux box, and a Windows 7 box, which is actually the host here. So let's look at a really wide open one because they're easy. That's not it. Where's my 2000? So you can see the MAC address, you can see status, whether it's been scanned or what. You can see the full service list and information that was found on it. If you look at the vuln list, you'll see there's no vulns yet because we didn't import a vuln scanner or use one. If you look at the share list, it should, there's no shares in this target. Evidence, no evidence has been collected yet, but we do have some notes. And these are kind of ugly still beta product. You can see that I enumerated all the user accounts and what IDs they were. So we have administrator, guest, iUser, IWAM, TS Internet user. So let's move back. And even though the scan process hasn't finished with unknown services, we can keep on just moving on. It doesn't really prevent us from going forward. So we're going to go through and do a brute force now. And you can see we've got all of our target IPs we found show up in the list. We can exclude stuff. We can add our own list of usernames and passwords to try here. We tell you the lockout risk for each protocol. So if it's SMB, it's probably going to lock it out if you don't configure it differently. Postgres, DB2, et cetera. Finally, you can say, do we want to automatically open sessions? Yes, we want sessions. Go. So this kicks off, and you'll see it goes through and tries to come up with an ordered username and password list for every target. So it's kind of hard to see on the screen here, but you'll see it's actually using the full username list off of the 2000 targets and then brute force other Windows machines as well. So even though it can't get the username listing off those other Windows targets because they're configured in a way that by default you can't do that, it's able to use leaked information from one target and then apply it to another, which is a great way to really go further in your pen test than you may otherwise or may not be able to do by hand. So as you can see, it already popped something over here. So we've got one host showed up with a notice on it. Let's go see what that notice is. And we can see now in the listing it shows cracked. So it got some kind of account on this target less than a minute ago. If you look in the notes table, we'll see, hey, I got an administrator with a blank password. So no surprise there. And we also found the guest account, but the guest account's disabled, so we added a note. If you do happen to lock out account, the lockout accounts will show on the bottom here. We're going to work on a better display for this. This is just currently the debug view of it. So the fun part is when it actually gets past the first round of brute force, it starts opening sessions. So we'll let that run for a second. And let's go ahead and kick off an exploit while we're at it. So we want to exploit everything. We don't want to exclude anything. Minimum reliability, great's fine. You can actually go down to average if you want most times without it being an issue. Concurrent exploits, 5 is fine. We only do one session per target. There's a couple cases where that doesn't quite apply, but it usually tries to limit it to one command shell per target. You just don't really need more than one half the time. Ignore fragile devices like your printers. Skip exploits that don't match the OS. So it'll actually do fingerprinting on and compare the OS. And if for some reason it doesn't hit it, you can always click that off and go. So that's going to go through and start chewing along. This takes a little while to go through and match it all up. It tries to first create the huge exploit list and then prioritize it based on the rankings, and then based on the rankings, then reorders them based on the most likely per target, ordered in reverse order. The reverse order stuff's not quite working yet in this demo, but it will be available for the public beta next week. So you can see it's going 2 out of 7 hosts have been matched up so far. My poor laptop here is chugging on 15 VMs right now, so it's a little slow. And let's see. Let's go look at our brute force task. It should have moved on at this point. Nope, still doing SMB. All right, that's what I get for loading this box down too much. So far we've